Hey everybody and welcome back. Get ready, because today we're diving headfirst into the mystery of prime numbers.
Prime numbers, eh? Always a fun time.
You know it. And you know we love a good mystery here. I got my hands on some really interesting sources this week, all about prime numbers, and let me tell you, they're anything but prime time predictable. They're more like prime time puzzling.
I can only imagine. So, what have we got on the docket for today's deep dive?
Glad you asked. So our main source this time around is this excerpt, and it dives right into the deep end, claiming that the distribution of prime numbers, the way they're spread out, it's fundamentally different from other mathematical patterns.
Fundamentally different, huh? That's a pretty bold claim.
Right, and that's what caught my eye. So I figured, who better to help us unpack this than a math whiz like yourself?
Well, you flatter me. But yeah, the distribution of prime numbers has been a puzzle for, centuries. It's one of those things that keeps mathematicians up at night.
So tell me, for us non-mathematicians out there, what makes this whole distribution of primes thing so special, so head-scratching?
Well, you know how in math we often find these nice, neat patterns? Like, take the sequence of even numbers, 2, 4, 6, 8. You can easily predict the next number, right?
Yeah, totally. Add two, easy peasy.
Exactly. And there are formulas for that, ways to express that pattern mathematically. But prime numbers, they don't seem to play by those rules. They're like those friends who are always fashionably late. You never know exactly when they'll show up.
Okay, I'm getting that. It's like trying to find a pattern in a lottery draw.
Haha, exactly. You got it. There's a degree of randomness, or at least apparent randomness, that we haven't quite cracked yet.
Now, our source uses this term, and forgive me if I butcher it, incommensurable. What's that all about?
Yes. Incommensurable. A great word. It essentially means things that can't be measured or compared using a common standard. Like, imagine trying to measure your height using units of time. It just doesn't work.
Whoa, okay, I see. It's like comparing apples and oranges,
Yeah.
but even weirder.
Exactly, you're on a roll. And that's the thing with prime numbers. Their distribution feels incommensurable with other mathematical patterns. It's like they're speaking a different language, one we're still trying to decipher.
Fascinating.
Yeah.
So how do we even begin to make sense of something so seemingly random?
That's the million-dollar question. And to answer that, we need to bring in the big guns. Our source actually connects this to, get this, Plato's Republic.
Plato, like the ancient Greek philosopher Plato.
You know it. It might seem like a strange connection at first, ancient philosophy and modern mathematics, but trust me, it's a fascinating link.
All right, you've piqued my curiosity. Lay it on me. What's Plato got to do with prime numbers?
Well, in the Republic, Plato describes this process of inquiry, a method of seeking truth called the dialectic process.
Dialectic process.
Okay,
Okay, that sounds a little intimidating. Can you break that down for us?
absolutely. Think of it like a conversation, a back and forth, where you start with some basic assumptions about a problem. You then question those assumptions, test them, refine them, and through that process, you edge closer to a deeper understanding of the truth.
So it's like a journey of discovery, but through dialogue and critical thinking.
Exactly. And you could say that mathematicians have been engaged in their own kind of dialectic process for centuries, trying to unravel the mysteries of prime numbers. They look for patterns, form hypotheses, test them, refine them, always pushing for that aha moment of understanding.
I like it. A mathematical conversation
Yeah.
spanning millennia.
Yeah.
But if prime numbers are so incommensurable, as our source put it, how do we even know where to start this whole dialectic process? Where do we begin our investigation?
Right. Well, that's where it gets really interesting. Plato didn't just give us the dialectic process. He also gave us a way to think about different levels of understanding, different ways of knowing.
Ah, okay. I'm intrigued.
Yeah.
Tell me more about these different levels. How do they play into all of this?
Sure. So Plato outlines 4 divisions of knowledge. We start at the base with perception. This is our immediate sensory experience of the world. It's like, I see a tree, but there's not much depth to that understanding.
Okay, makes sense. What's next?
Above perception, we have faith. Now, this isn't necessarily about religious faith, but more about accepting things based on authority or tradition.
Right, accepting things at face value.
Exactly. And while faith has its place, it's not enough for true understanding. Then comes understanding, which Plato considers a higher form of knowledge. This is where we start forming connections, making logical deductions, but we're still working within a framework given to us.
We're not quite at the top yet, are we? There's still reason, right?
Yeah. You got it. And this is the peak. Reason, for Plato, represents the highest form of knowledge. It's about grasping the underlying principles, the fundamental truths that govern reality.
So are you saying that with prime numbers, we're still stuck somewhere between understanding
Hmm.
and reason?
That's an insightful way to put it. We have all these amazing tools, sophisticated algorithms, powerful computers, crunching numbers. But even with all that, there's still this sense that we're missing a piece of the puzzle, that we haven't quite grasped the fundamental why behind the distribution of prime numbers. We haven't reached reason just yet.
Wow. That's kind of humbling in a way, don't you think? That something as seemingly simple as prime numbers can lead us to these profound questions about knowledge itself.
It is humbling, isn't it? And it highlights the beauty of mathematics, really. It's not just about crunching numbers, it's about grappling with the deepest mysteries of the universe.
I love that. So for our listeners out there, what's the one big takeaway from today's deep dive? Why should they care about these seemingly random prime numbers?
Because prime numbers aren't just some abstract mathematical concept. They're a challenge, a puzzle that pushes us to the very edge of what we know and forces us to confront what we don't. They remind us that the pursuit of knowledge is an ongoing journey, one filled with wonder, frustration, and the occasional aha moment that makes it all worthwhile.
Absolutely. And who knows, maybe one of our listeners will be the one to finally crack the code, to reach that platonic ideal of reason when it comes to prime numbers. Thanks for joining us on this deep dive, everyone. It's been a mind-bending ride.